in a physics class. We were doing chapter number 3, machines, in which in my last video I told you about pulleys. There are two types of pulleys, single fixed pulley and single movable pulley. Now you also did the differences between them, that a single fixed pulley has a mechanical advantage of 1 and velocity ratio also 1. But a single movable pulley has a mechanical advantage of 2 and velocity ratio 2. But sometimes a heavy load has to be lifted from one place to the other. So in that case, we cannot use single movable pulley also, which has mechanical advantage only equal to 2. So we require a pulley whose MA is more than 2. There we used a combination of several pulleys. So we will do in our chapter 2 such combinations. The first combination is that in which there is one fixed pulley and other movable pulleys. It depends on the mechanical advantage. One is fixed but the others are movable. And the second combination is that you use several pulleys in two blocks. The upper block is fixed and the lower block is movable, and you use several pulleys in both the blocks. So this diagram shows the first combination in which we use one fixed pulley and the other movable pulleys. This is the single fixed pulley. This is single movable pulley. This is also single movable pulley, and this is also single movable pulley. So here we are using one single fixed pulley and three movable pulleys. They are all attached with the strings. The effort is applied at one end of the single fixed pulley, and the load is attached to one end to the lower end of the movable pulley, to one movable pulley. So here tension forces are acting on each string of the pulley. So these tensions are taken to be T1 and T1, T2 and T2, both will be equal forces, T3, T3, and here also T3. So the effort E is balancing this tension force T3. Now this load is balanced by two tensions, T1 plus T1. That means 2T1 equals to L. That means T1 equals to L upon 2. Similarly, T2 plus T2 are balancing this tension T1. That means 2T2 equals to T1. Therefore, T2 will be T1 upon 2. Here we have put this value of T1, L upon 2 in this equation. So T1 is L upon 2 upon 2. So this becomes L upon 2 into 2. We can write as 2 square. So this becomes L upon 2 square. Similarly, T3 and T3 are balancing this T2. So 2T3 equals to T2. T3 is T2 upon 2. We substitute the value of T2 here. This value, L upon 2 square we are putting here. So it becomes L upon 2 square upon 2. So it becomes L upon 2 cube, because L upon 2 into 2 into 2. So it becomes L upon 2 cube. That means load equals to 2 cube into T3. We have cross multiplied this. Therefore, mechanical advantage equals to load upon effort. How much is the load? 2 cube into T3. And how much was the effort? T3. T3 cancels, so mechanical advantage equals to 2 to the power 3. So in general, if we are using n movable pulleys, the mechanical advantage equals to 2 to the power n. This n is the number of movable pulleys, because single fixed pulley is always 1. There are different numbers of movable pulleys. So mechanical advantage equals to 2 to the power n, where n is the number of movable pulleys. 3 movable pulleys are used, it becomes 2 to the power 3, means 8. If 4 movable pulleys are used, then mechanical advantage becomes 2 to the power 4. That means in that case it is 16. Now we will find the velocity ratio of this combination. As one end of each string is fixed to the rigid support, the other end moves twice the distance moved by the axle of the movable pulley, this axle. So if load L moves up a distance x, this end which is connected to the axle of the pulley, the how much will the string of the seam move? 2 into 2x, that means 2 square x. And the string connected to this B will move 2 into 2 square x, that is 2 cube x. So in every case, here, every time the distance moved is double. So the velocity ratio is equal to displacement of the effort to the displacement of the load. When the displacement of the effort moved by this string is 2 to the power 3 into x upon, and BL has a load has moved for a distance of x. X cancels, so velocity ratio equals to 2 to the power 3. So in general, if there are n number of movable pulleys, the velocity ratio becomes 2 to the power n. Therefore, now easily we can calculate the efficiency. Efficiency equals to MA upon VR. MA was also 2 to the power n for general number, and VR is also 2 to the power n. So efficiency becomes 1 or 100%. But this is only in the ideal situation. In actual practice, both the weight of the pulleys and the string and the friction between the bearings of the pulleys reduce the mechanical advantage. Velocity ratio will not change, it will remain fixed. But the mechanical advantage will be reduced and the efficiency of the system will become less than 100%. Now the second combination is using several pulleys in 2 blocks, and this is known as block and tackle system. In this system of pulleys, 2 blocks of pulleys are used. One block, which is the upper block, is fixed to the rigid support. That is, it is fixed. And the lower block is not fixed to the rigid support. That means it is movable. This is the upper block, this is the lower block. This is the upper block, this is the lower block. Now the number of pulleys used in the movable lower block is either equal to or less than that of the fixed upper block. Children, see carefully. This diagram is not complete. I have drawn only the pulleys, number of pulleys in the blocks to make you clear. In this, total number of pulleys are 5. 1, 2, 3, 4, 5. The upper block will have 3 pulleys and the lower block will have 2 pulleys. Because the lower block can never have more pulleys than the upper block. Either they should be equal, like if they are total 4. So 2 in the upper, 2 in the bottom. But if they are unequal, so more number of pulleys will be the upper fixed block and the less number of pulleys will be in the lower fixed block. So here 3 pulleys in the upper block and 2 pulleys in the lower block. Here 2 are there in both of them. Suppose there are 6 pulleys. So how will be there? 3 and 3. But if there are 7, then 4 in the upper block and 3 in the lower block. Now a strong, inextensible string or rope of negligible mass passes through all the pulleys. One end of the string is attached to the hook of the lower block, or it is attached to the hook of the upper block if the number of pulleys is more. This I will show you while I am drawing the diagram. You have to see carefully. So here we have to apply the effort in the downward direction. Although with the help of these pulleys, always we have to apply the effort in a more convenient direction, that is the downward direction. Now I will show how the string passes through this block. So we will start with the uppermost pulley. Then we will go to the last. Then second one. Then the second last and this third one. So the lower end of this pulley get attached to this hook of the lower block. The effort is applied at this end in the downward direction. Tensions T act in all the strings. T equal forces and in the upper direction always. T acts in the upper direction. T, 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 T and T. So total how many tensions? Count. 1, 2, 3, 4, 5 and 6. Number of pulleys are 5, so total tensions will be 6 because 5 tension is supporting this load and 1 tension is supporting the. Here the last is joined to the load. Now let's see this. We'll start from here, topmost, then bottommost, then second, this, and ultimately goes to joint is here. The hook of the upper fixed. See, this is the difference in the diagram. Here the lower end is joined to the hook of the lower block. If unequal and if equal, then it is joined to the hook of the upper fixed. Same way effort is applied in the downward direction, load is applied here. Tensions T, 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 T. So 4 pulleys are there. So how many tensions will be there? 5. 1, 2, 3, 4 and 5. 4 tensions are supporting the load and 1 tension is supporting the F. But the tension along the entire length of the string is the same forces acting in the upward direction. Now how to find the mechanical advantage? In the first diagram which I have drawn, in which the number of pulleys were 5, here the tension in the 5 segments is supporting the load L. That means L equals to 5T and 1 tension is supporting the effort T. That means E equals to P. So mechanical advantage becomes load upon effort. 5T upon T. PT cancel, that means 5. Suppose there are 4, then L will be 4T, effort will be T. So now it will become 4. So in general, mechanical advantage equals to N, means number of pulleys. Now velocity ratio is given by the displacement of the effort to the displacement of the. So if there is a system containing N pulleys and the load goes through a distance T, each segment of the string supporting the load is loosened by a distance T. So the effort moves through a distance NT. That means displacement of effort is NT, displacement of load is B. So it can be cancelled. So velocity ratio equals to N. And what is N? N is again equal to the total number of pulleys. Total number of pulleys. That means efficiency becomes MA upon VR. That means N upon N, which is 1 on 100%. But again, this is only in the ideal situation. In actual practice, there is always friction in the bearings of the pulleys and the weight of the string along with the weight of the lower block with the pulleys. So the mechanical advantage decreases. Children, I am stressing on this word. Always the mechanical advantage decreases due to friction and weight of the block. Velocity ratio will remain the same. So the efficiency becomes less than 100%. The efficiency of the machine decreases. Okay, children? Now, children, this chapter is completed. So let's do the numericals of exercise 3B. Okay. So I'll do question number 1. Because in exercise 3A, almost all the numericals are based on levers and levers are not in your course. So we are doing numericals of exercise 3B. So question number 1 is that a woman draws water from a well using a fixed pulley. The mass of the bucket and water together is 6 kg. The force applied by the woman is 70 Newton. Calculate the mechanical advantage. Now, since the bucket and water, they are the load. So, what is the total load? 6 kg. That means 6 into 10, 60 Newton. You have to convert in Newton. So, effort applied by the woman is 70 Newton. So, what will be mechanical advantage? Load upon effort. That means 60 upon 70, which comes out to be 0.857. And you already know that mechanical advantage has no unit. Now question number 4 I am doing. In a block and tackle system consisting of 3 pulleys, a load of 75 kgf is raised with an effort of 25 kgf. Find MA, VR and efficiency. Now MA is given by the formula of load upon effort. So 75 kgf of VR equals to 3 and efficiency is given by MA upon VR into 100%, which becomes 3 upon 3 into 100% means 100% efficiency. You know 100% efficiency, both MA and VR are equal. Otherwise MA is less than the velocity ratio.